Hey, welcome. Today, we are diving into a single piece of technology that is, no joke, fundamentally changing how we solve problems, from the tiniest microscopic details to massive global challenges. All right, let's start with a bit of a mystery. What in the world connects a doctor diagnosing a super rare disease, an app on your phone flagging a fake news article, and an airplane's critical safety system spotting a fault before it becomes a problem? I mean, these things seem worlds apart, right? But they all run on the exact same powerful engine. And the answer? Well, it isn't some shiny new gadget or a single invention. It's something much, much bigger. A universal toolkit for solving problems. And today, we're going to open it up and see what's inside. That answer is machine learning classification. Yep, that's the invisible thread connecting all those different fields, and honestly, countless more. So what the heck is it? Well, to put it simply, classification is all about teaching a computer how to sort things. You show it a ton of examples that are already labeled, like, say, thousands of pictures of cats and dogs, and it starts to learn the rules on its own. Then, when you show it a brand new picture it's never seen before, it can pretty accurately say, yep, that's a cat, or that's a dog. It's basically a digital sorting hat from Harry Potter. The best way to think about this whole thing is to picture a digital Swiss Army knife. It's not just one tool, it's a whole collection of them, and depending on the specific problem you need to solve, you just pull out a different attachment. And here are some of the star players in that kit. You'll see names like decision trees, which kind of work like a super smart game of 20 questions, and neural networks, which are actually inspired by the wiring of the human brain. Now, don't worry about the jargon right now. The key takeaway is that each one of these is a unique tool for sorting data, and we're about to see them in action.
Okay, so having an awesome toolkit is one thing, but how do you actually use it to build something? How do these algorithms go from just being code to solving real tangible problems?
Well, it usually follows a pretty standard recipe. First, you gather up all the data you need, say thousands of customer reviews for an app. Then you have to clean it all up and get it ready, which is called pre-processing. Next, you pick one of those tools from your kit and you build a model. And finally, you have to test it and see how well it actually did its job. All right, theory's done. We've got our toolkit. We know the basic workflow. Now let's see what happens when we apply it to some of the highest stakes fields you can imagine, our health and our security.
First up, let's talk about advanced medical diagnosis. In this case, the categories we're sorting aren't cat or dog, but something way more serious, like healthy versus unhealthy, or trying to identify the unique signature of a specific disease.
What's so fascinating here is seeing how different tools are picked for different jobs. For something like detecting COVID-19 from medical scans, a special kind of neural network called a CNN might be the best because it's amazing at spotting visual patterns a human eye could easily miss. But for a rare neurological disorder, a decision tree might be better because its logic is way easier for doctors to look at and actually understand. The point is, the toolkit is adaptable. You pick the right tool for each specific challenge. This toolkit is also one of our main lines of defense in our digital lives. Every single day, cybersecurity systems have to sort through billions of pieces of data and classify them as either safe or malicious. And this highlights a really critical lesson for the real world. The best tool isn't always the one that's the most accurate. I mean, when you're defending against millions of potential attacks every second, being incredibly fast and 99% accurate is way better than being 100% accurate but too slow to keep up. It's this constant trade-off between perfection and just getting the job done. So, we've seen how classification protects us. Now, let's switch gears and see how it helps us just make sense of the incredibly complex world all around us. How do companies figure out if people love or hate the latest update to their app? Well, they use classification to do something called sentiment analysis. It automatically reads and sorts thousands of written reviews into buckets like positive, negative, or neutral. And you know what? These tools are getting insanely good at it. In one study that analyzed app reviews, one of these classic algorithms achieved a stunning 96% accuracy. And here's the proof. A tool called a linear SVC, which is a type of support vector machine, is what hit that 96% mark. And another classic, multinomial naive Bayes, was right on its heels at 95%. This is the real power of classification, turning messy, subjective human language into structured, measurable data. And it goes way beyond the digital world. Classification is also being used to optimize our physical environment, like, for example, making the traffic in a big city flow a lot more smoothly. Now, to solve a messy problem like traffic, researchers are pretty much throwing the entire toolkit at it. Just look at this list. From random forests to something called gradient boosting, they're testing everything to see which algorithm can best classify traffic conditions and make that perfect split-second decision. It's a total battle of the bots. And the list just goes on and on. The very same principles are used to classify how engaged students are in a classroom, to spot fake news articles before they spread, and to verify your identity using your fingerprint or your face. It is truly everywhere. So after all that, what does it all mean? Let's bring it all together and ask the big question. Is this toolkit some kind of master key? I think this quote really nails it. The fact that the exact same fundamental tools, the same algorithms from our digital Swiss Army knife, can be used for problems as wildly different as reading an app review, finding a computer virus, diagnosing a disease, or directing traffic. That is just absolutely profound. You see, machine learning classification isn't just one more cool piece of tech. It's a foundational building block for our modern world. It's a way of creating order out of chaos, of finding patterns in the noise, and for making smart, automated decisions at a scale we humans could never even dream of. So the power is obviously there. This toolkit can learn to classify just about anything we can measure. The real question isn't what can it do anymore, it's what should it do next? If you had this universal toolkit in your hands, what's the first problem you would try to solve?